This week, we go deep into artificial intelligence with talking computers,
Goodbye. Have a nice day.
leaping lions, and singing cowboys. What is artificial intelligence? Should it be smarter than us? Does it need to learn from its mistakes? Should it be conscious?
Yeah, I really like to say artificial intelligence, not about the consciousness of a machine, but it's really about getting help. We feel better when we're using it, not that it's in control of us.
I mean, the scary thing comes in when the machine learns to fake that it doesn't know to do it because it doesn't want to be caught doing it.
A good test of intelligence is to be able to follow instructions like we do, understand language like we do, and understand what it sees like we do. But if an artificial intelligence can do that, will it be the end of us?
It'll be like another industrial revolution. I think the whole job markets will change.
The biggest difference between this and the Industrial Revolution in the 1800s is the speed with which the cognitive revolution will come.
There's research into artificial intelligence going on around the world, but we've decided to start our tour in New York. About an hour north of Manhattan lives possibly the most famous example of a smart machine. Certainly the one that beat us humans at our own game.
Now we come to Watson, who is Bram Stoker and the wager. Hello.
Watson is what its creator, IBM, calls a cognitive system. Fill it with unstructured data and it will analyse it, make connections, derive conclusions and learn from its mistakes. And it will then allow you to interrogate it using English language questions.
Watson reads. It has an unbelievable appetite for information, for books, periodicals, blogs, tweets. But more importantly, it not only reads but understands. It's able to put that vast amount of data in context. Watson learns. With interaction, with use, with feedback, it actually gets progressively smarter.
Well, here he is. This is the Watson that won Jeopardy. 1, 2, 3, 4, 5 racks here and another 5 behind. That was what it took to beat the best of the best human contestants in 2011. Since then, technology has marched on, and today, the Watson with this power would actually be that high and that wide. But what's much more important is that these days IBM is offering Watson's abilities to the world. Watson now lives in the cloud, although it is categorically not Skynet. Okay. These days, you can have your very own empty version of Watson. Load it with whatever information you want and it will go to work on it. Like Chef Watson, which is cooking up wacky new recipes by analysing cookbooks and working out what ingredients are chemically compatible with others, even if they sound like vile combinations. All round to mine for sprout and custard roulade then.
Wow, guacamole and curry paste.
What's cool about Watson is that you interact with it, you don't query it, you don't set something up, you literally ask it a question. You give it text. It rips apart the text. It gets the context.
Can we ask Watson something now?
What is snow? And
the
then
white stuff in winter, particles of water vapour, Vapor spelled incorrectly, because I'm speaking English. So that's really it. I mean, Watson really does do
matches it to a
everything in
statement.
between.
Yes.
You say what is snow, and it returns that. The team at Elemental Path Labs in New York City are developing a toy dinosaur which uses Watson to answer questions from inquisitive children.
Watson's a little bit more complicated in that we boil it down to just what's being said by the toy, that one line. But on the back end, what Watson's actually returning is all of this, which is
that's more
this is
right there.
This is the evidence behind how did I evaluate that that is the right thing to respond with? What is the confidence level, an actual mathematical interpretation? Like there is a 75% chance that I believe that this is the answer to that statement. And it has the evidence behind that, other facts that are wrapped around it, it gives the context for it. So you really can drill down on the meaning of what's being said, other than just that flat statement that, oh, this is the answer to your question.
Hi.
Hello there. What's up?
Whose idea was it to make it the love child of the Cookie Monster and Yoda? And that was basically my entire school life when it came to sports. Tell you what, let's leave it to the big boys, shall we? Welcome to the Copper Box Arena. Built for the London 2012 Olympics, it's now home to the London Lions, one of the UK's only pro basketball teams. And of all the people on court, this guy is one of the most vital. This is Laurent, one of the coaches, and he really knows his stuff.
Balls to the wing, looking at the low post. We got our two biggest men come to the top to set a screen for the ball man. We get one guy diving.
The coaches know how the team plays, its strengths and its weaknesses, and it's their job to figure out how to play to win. But that could soon be about to change. There's a new coach sitting courtside, and where we see players, it sees this. Rajiv Maheswaran is CEO of Second Spectrum in the US, which is working on a system that uses artificial intelligence to look at this data and see much more than just moving dots.
A machine can watch every single instant of every single game, and so it has the ability to sort of recall every single moment and add it all up together, and that's a capability that people just don't have.
The idea is to analyse these dots and see things that coaches see, like moves, tactics and strategies. For example, one team manoeuvre that serious players of the game will recognise is something called a pick and roll. And it goes a bit like this. You've got two offensive players in white, two defensive players in black. The guy with the ball comes here and calls his teammate in, who blocks the defence. That's the pick. Now the other guy goes over here, passes the ball. That's the roll. I hope that's clear. Good, because this is also a pick and roll. That's a pick and roll. That's a pick and roll. That's a pick and pop, which is also a kind of pick and roll. The point is that pick and rolls come with thousands of tiny variations, and being able to recognise that they're all essentially the same thing is what's so hard. Artificial intelligence, however, is really good at solving problems like this. By showing an AI thousands of examples and saying, this is a pick and roll, this isn't, it can eventually figure out on its own what makes up the move, what the essence of a pick and roll is. The same works for other moves too, of course, and if you can figure all that out, then all of those random dots suddenly become a lot more useful.
Now we understand that there's a dribble handoff between these two players, and this player is playing an over defense, and this player is playing an up to touch defense, and all of this we get because we can turn all this movement into meaning.
And when you have all that rich, tagged up data of hundreds of hours of play all in one place, you can start to do things that coaches can't do. Like figuring out precisely how good a shot is, by looking at things like the shooter's angle to the basket, where they are relative to the defenders, what type of shot they make, how they move, how fast they shoot, and loads of other variables. You can put a number on how hard that shot was to make. With data like that, you get to see how good and therefore how valuable a player is. Are they a great shooter who only attempts hard shots, or are they a bad shooter who only attempts easy shots? This software is now being used by more than a third of NBA teams in the US, but it could also change the way that we watch sports at home.
So right now, broadcasters make a highlight that they hope will serve many, many people, but there's no reason why you couldn't have a highlight package just made for you. It might look like, show me all the dunks from the game that I missed tonight, and explain to me why the team won and why the team lost, and should we trade this player for another player? And you can have a machine that sort of interacts with you and shows you the content you care about because it understands you and it understands the game.
Second Spectrum's big focus is basketball, but there are plenty of other dots in the world, from other sports to location data from our phones, that we don't fully understand.
There's a lot of data about how we move coming around, and I think there's a lot of value in understanding how we move. If we get a fundamental understanding of what's going in there, we can make things better. We can make better cities, better buildings, better houses, and understand ourselves better. And I think there's a lot of value to be gained in that. There's a lot of that already going on, but I think we're only scratching the surface of what is possible.
Away from the world of hoops, and it was the week that Facebook revealed it's to introduce a dislike button, although it'll be for empathising with sad news and not so we can be horrid about more pictures of our friends' babies. I repeat, it's not to dislike other people's babies. Sony's Project Morpheus morphed into the rather less cool-sounding PlayStation VR, and Microsoft is scrapping its online music service, Zune. Now, if you've never heard of Zune, don't worry. That's why they're scrapping it. This week also gave us some very cool footage from the Defence Advanced Research Projects Agency, or DARPA as they're known to their mates. They've invented landing gear with knees. Now, we couldn't leave you without the tech highlights from the Frankfurt Motor Show this week. From Frankfurt. Peugeot showed off its electric fractal model that contains 3D printed parts, and warns pedestrians it's coming their way by making this sound. Decent bit of kit. You should hear it talk. It doesn't talk. Porsche unveiled its four-door Mission E electric concept car, which has a lovely red light across its backside. Bugatti showed off a real-life version of its Vision Gran Turismo. And Mercedes-Benz offered up its intelligent aerodynamic automobile, which changes shape once it goes over 50 miles an hour. And is it up for a chat?
I was working as a currency trader, and I got a call one day from my mom saying that my dad was having trouble finishing his sentences. They did an MRI and found 3 unidentified masses in his brain, which turned out to be glioblastoma multiforme, which is the most common and aggressive brain tumor in adults.
Matt De Silva's story is in many ways very similar to anyone who's lost someone to cancer. But it becomes extraordinary when you hear about his ambition to revolutionise the way that we treat the disease.
When we put together 3 drugs, especially drugs that don't do anything individually, we see a strong effect of killing that tumor.
In his lab in San Francisco, Matt is looking to develop a treatment method that could be custom-made for each patient. The idea is to combine off-the-shelf, already approved medicines to create a drug therapy regime that results in shrinking tumours and hopefully complete recovery. Many drugs that are sold at pharmacies today are known to have other side effects. Perhaps the most famous of all is this little blue pill. Viagra was first developed to treat high blood pressure, but during its trial phase it was discovered even though it wasn't a very good heart medication, it could treat male erectile dysfunction. The problem is there are far too many approved drugs on the market containing many different chemical compounds. To test all the possible combinations in a lab is, well, impossible. This is where artificial intelligence comes to the rescue. Notable Labs has partnered up with Atomwise, a company that's developed an intelligent algorithm that can simulate how an illness attacks the human body and, more crucially, test chemical compounds artificially to see which treatments would be most effective in blocking its progress.
If you try to, as a human, consider all the possible factors that relate to each of these interactions, it could take a lifetime. You're dealing with hundreds or thousands of concurrent factors that interact in very highly nonlinear ways. But that's something that Atomwise, being an artificial intelligence system, is able to do with relative ease. It teaches itself what is most important. It studies millions or tens of millions of examples of what we already know from the whole assemblage of scientific literature on the effects of medicines and the proteins that they interact with. In addition to these things that we can understand as humans with chemical experience, it has also taught itself thousands of other things that we don't understand, that are counterintuitive or unintuitive to us.
Atomwise's algorithm narrows down the possible combinations from millions to just a few hundred. Back at Notable Labs, these combinations are tested on real cancerous cells that have been taken from patients.
This was a patient that had surgery here in San Francisco about 3 weeks ago. And so we're waiting for their cells to grow and form spheres. The reason we want their cells to form spheres are because we want it to be like miniature tumors. Because when we test it with drugs, we want to make sure that what happens here will translate back to the patient themselves.
Matt is hoping to certify his method within a year so he can treat large numbers of people. And if it really does work, we could start treating some cancers with medications that are already sitting on a shelf and also massively cut the costs of those treatments.
I feel very blessed that I left my job at the hedge fund in June, and he passed away the following February. So he actually did see the beginning of the company. And even actually is one of our cell lines that we have here. So his tumors are behind us. We're actually growing them still. So it's a bit melancholy for me to think about that. But when I think about his contribution and his legacy in this company, it gives me a lot of peace.
Many big cities around the world are vivid reminders of how different we all are. For an artificial intelligence to make it in this world, well, it needs to understand us as well as any human can.
This is Wall Street.
Everyone has a different way of talking and interacting. On the West Coast, for example, they'll probably sugarcoat what they're saying. Here in New York, not so much. They might sing you a song, though.
Well, I'm hanging out with Spencer here on the click. Please do not look at my...
Dictate anything into your phone and you'll see how not perfect speech recognition is. If the computer mishears your words, the AI will end up answering the wrong question and it'll end up looking more stupid than it really is. But when speech recognition does work, you really can feel like you're in the future. Celia, show me companies with revenue between $25 million and $60 million pertaining to analytics.
Okay, I'll try to find those companies for you. I found 87 companies.
Back at IBM's Thomas J. Watson Research Center just north of Manhattan, I'm asking Celia to help me make a very important decision. Which company to buy with my gargantuan BBC salary? Celia, explain your reasoning.
Here's an explanation.
One of the problems we have as humans is that I think we think ourselves as better decision makers than we really are. The reality is we don't do complex decision making very well, and we're subject to biases. Buying a company, drilling an oil well, these are hugely expensive. You want to do it right. So you want to reduce uncertainty, manage risk, all of these kinds of things. That's what these systems of the future should be able to do, help us become smarter.
Celia is actually Watson in a wig, and he or she aims to advise on the best buy without any of those biases, the unconscious preferences and assumptions that a human may fall foul of. Celia, thank you. Goodbye.
Goodbye. Have a nice day.
That is a beautiful thing. It's a beautiful thing. It's a beautiful thing. And if AI can help with buying whole companies, it's not a big stretch to imagine it also working here. It's a place where instant decisions can really make or break you, where tensions run high and impair judgments. At least for humans. Here in the offices of Sentient Technologies in San Francisco, an artificially intelligent computer program is doing something that sounds amazing. It's writing another computer program. One that may one day become the hottest, sharpest stock trader in the business. This type of AI is called an evolutionary algorithm. Give it a task, a problem to solve, in this case, make money in the stock markets, and it then sucks up as much historical and real-time trading data as it can. Then it starts breeding algorithms that are designed to trade successfully.
Initially, when you generate that first population, they're all pretty bad because you're generating them completely randomly. But some are less bad than the others. So then you can kill off most of these candidates, you retain the ones that are better, and you make use of bits and pieces of what was authored in those less bad candidates in generating the next population. You still have a healthy dose of randomness going in there as well. But through many, many generations that can be massively distributed over many, many machines, you gradually converge to solutions that generalize sufficiently.
This method doesn't just work with stock trading. The AI can be applied to many different problems, including, for example, predicting medical conditions in our own bodies.
Sepsis is the biggest killer in hospitals and in ICUs. And the telltale sign of that is a drop. Severe drop in blood pressure. And so absolutely, if you can predict that a septic shock is going to happen 30 minutes out, you can intervene.
Now, instead of just relying on one server to do all of its processor-intensive learning and computation, the AI harnesses the power of thousands of idle machines sitting in data centers across the globe, which are only there to handle possible surges in internet traffic. It's looking for the most effective, efficient generation of the algorithm. And once it's found it, this relatively short computer program can be downloaded to a user's mobile device.
Actually have your models trained a priori offline, let's say in a distributed manner somewhere. Then you can actually apply the models themselves on processing capacity that's already available on your phone. AI can enable us not to have to move our personalized data, especially distributed AI, off of our devices.
So, we've gone from a massive AI that beats humans at quizzes all the way to AIs which breed better computer programs. Yes, it does sound a bit like the movies are upon us, doesn't it? Although, of course, we are not quite at the singularity just yet.
Yeah, sure, we are nowhere near having machines that are conscious, that can think for themselves, that are self-aware, but I can't help thinking that there is some kind of quiet revolution going on behind the scenes that might change the way the world works in a few years' time. So yeah, we don't have to be worried for humanity at the moment, but I get the feeling something is coming.
And next week, we're going to bring that something to life as we use what we've learned to build our own artificial intelligence. There will be running, there will be screaming.
Massive laboratory!
And the machines will rise.